Hi and welcome to ISPI. Today I'm gonna make a benchtop power supply from a computer ATX power supply, which has 3 fixed voltage outlets, 1 adjustable voltage outlet, and a USB outlet which can be used even when the power supply is turned off. This is the power supply I'll be using. I've already measured all wires to be sure that it works properly. First, I make a rough 3D model of the case with Fusion 360. Then I cut all the parts for the basic case from 12mm MDF. To glue up the side pieces with the top piece later, I cut miters. Next, I change the blade to cut grooves for the back and front panel. If you wanna know how I built my saw blade storage unit, there is a link in the upper right corner. And if you are interested in some other cool projects like this, go and visit my channel. There are a bunch of such videos. And if you haven't subscribed yet, please do that as well. I set the height of the blade to 5mm with my self-made digital height gauge and cut all the grooves. Next, I glue the pieces for the top case part together. I will use the bottom case part as a spacer while I fix it with tape. To be able to screw the bottom part to the top part of the case later, I glue in 2 strips. Then I drill the holes to screw on the bottom part. Next I use the screws itself to mark the spots for the pilot holes. And I sand away small imperfections with my ultimate sanding block. I take the case to my router table and round off all outer edges. Unfortunately, I've forgotten to route the chamfers on the inside edges before gluing, so I make them now and finish them by hand. Before I apply a coat of primer, I give the case a quick hand sanding. This primer closes the pores of the MDF. In this way the paint will not be sucked in, especially on the edges. After the primer has dried, I screw the case back together and give it another sanding. For painting the case, I've set up my portable spray paint booth. I apply 3 layers of paint and 2 layers of a clear coat. In the meantime, I use Fusion 360 again to design the front and back panel. For my power supply I don't need all the wires, so I open the case and clip off all unnecessary wires directly at the circuit board. Actually, I just need 7 colors. Yellow for 12 volts, red for 5 volts, orange for 3.3 volts, black for ground, green for power on, grey for power good, and the purple one for standby 5 volts. And then I screw the unit back together. Next I stick some rubber feet to the bottom part and test if the ATX unit fit properly. These are the finished front and back panel. I 3D printed them, but they can also be made from wood or sheet metal. It looks really nice to me. Because I don't need such long wires, I clip them to the right length and add wire ferrules. For the 12, 5, 3.3 volts and for ground I use 3 wires and crimp them together with 1 ferrule. Here are the components I use. 3 voltmeters, a USB port with the associated wire which has a fuse, a on-off switch, a resistor for a permanent load, a fuse holder wire, a digital adjustable power supply module, some fuse holders, of course some fuses, and some binding posts, and of course some screws. Next I mount all components to the front panel. I don't screw the voltmeters yet because I don't have the right screws on hand. I 3D printed an additional bracket which holds the ATX power supply on the bottom plate, and the terminal strip, we call it Lüsterklemme, can be attached to as well. Then I screw the back panel to the power supply and screw it with the bracket to the base. Next I connect all the wires to the terminal strip. Because I have cut the wires for the resistor too short, I extend them again. And then I solder the resistor on. The screws I bought to attach the voltmeters are still too long, so I 3D printed some spacer rings to compensate. Then it's time for wiring. I will show you the wiring on a simple schematic. Here are all components I mentioned earlier, and on the left side you can see all the wires which come from the ATX. Two additional components which I don't mention earlier are two step-up converters. One which converts 5 volts to 12 volts, and one which converts 12 volts to 24 volts. The actual wiring is pretty easy. A wire from each of the voltage outputs goes to a fuse holder, and from the fuse holder to the binding post. And from the ground goes a wire to each binding post as well. The voltmeters are just wired between the binding posts of each voltage. Another wire from 12 volts and ground goes to the upper step-up converter. And the 24 volts are then wired to the digital adjustable power supply module. The positive wire goes through the fuse holder. The outputs then are wired to the binding posts. The resistors are just wired between 5 volts and ground. The PS on wire and the ground wire goes to the switch. I wanted the power good LED to be integrated in the switch, but I had just a switch laying around that needs 12 volts to light up properly. That's the reason why I have to wire a step-up converter in between. If you use another switch, you can maybe go direct with 5 volts to the switch. And last, the standby 5 volts and ground are wired to the USB outlet. And this is how it looks when it's wired. It looks a bit confusing, but it's pretty easy to do. Next I connect the wires to the terminal strip and set the step-up converters to the proper voltage. I secure the upper converter with zip ties. Then I glue the other converter and the resistor in place by using hot glue. Here you can see that I had to make some cutouts to prevent any collision when I slide the top on. I screw the case together and make some final measurements. Here you can see that the USB outlet can be used even when the power supply is turned off. Everything works properly and I'm very happy with this thing. Thank you for watching. If you like my videos, please consider subscribing, don't forget to click the notification bell and stay tuned for future projects. See ya!